Hi guys, welcome to my channel. Today I wanted to talk about the Simulink, and to start with Simulink we go and look at a basic system, input and output system. Okay, Simulink is a strong software that we can use it for modeling engineering systems, and I wanted to go over all many of this engineering software and explain them during the time that I have, extra time that I have, so hopefully it is going to be useful to you. I have started, from today actually start the live video, so you are welcome to join later on. I am going to make an announcement about the date, and you are welcome to do as I am doing and write your comments and ask your question, and I'm happy to answer that and explain so that it is going to be useful to you. Okay, for Simulink, how is it working? First of all, you need to have MATLAB. Okay, if you have Simulink package, then you can go and click on the Simulink, or the other way is that you can just write Simulink and run it. There are different options available to us. I go for the simple one for now, the blank model. So suppose you want to start with this, and obviously we're gonna have a blank model, so that's what we call it, a blank model. Here we have a library, and this library has all the features we require. Okay, when we open the library, we're going to have all the databases that's available to us. Under the Simulink, okay, you can see the Simulink or any other database. Today is the starting day, so we go for a simple model. I go for a sync. Sync means what is it showing, or what is take the data. Okay, there are different options available to us. The one I wanted to go is a scope. Means basically oscilloscope, or showing the signal. Okay, this is the oscilloscope. And then for the next one, I need a source, means the source of signal. There are different sources available to us. Obviously, as you know, the simplest wave that we have is a sine wave. So I add a sine wave. You can replace that with any other. And then you can see that one of them is a source, so it's pointing out, and another one is a sink pointing in. So we need to connect these two together. As we move the mouse, you can see that it is showing a plus. And now if I hold and click, I can connect one model to the other one. Now connected. And I leave my finger. Now basically we have done with our first program. Congratulations. And we can run it. It takes some time. It's pretty quick because this program doesn't have much information. And we can click on the scope and see our wave. Impressive, isn't it? That's a nice, beautiful sine wave, as we can see. Okay, obviously that was the simplest one, but we need to be able to modify the sine wave and design sine waves that work for us, and also modify other features. Okay, so let me close this. Now I wanted to choose a sine wave that works for me. Okay, so I click on the sine wave. Okay, for now let's not touch any of these features. We have time based and we have your simulation time, so let them to be as they are. Okay, we have the amplitude, how much the amplitude of your signal going to be, like VP, the peak voltage. For example, let's say 100. I'm saying voltage because I am electrical engineer. Obviously, when you simulate that, it could be vibration, it could be wave, or it could be all other engineering um, signals. Bias is a DC value. Do you want it to have a bias? Yeah, for example 10. Frequency. Well, frequency here is written in radian per second. How much the frequency want it to be? For example, if you wanted to use 60 or 50 hertz, well, then you need to convert it. But do not worry, you don't have to convert it outside. You can convert it right here. For example, if it is 50 hertz, okay, we know that 50 hertz, every hertz is 180 divided by pi. So see, pi actually, it understands the pi as a function. Okay, so 50 times 180 by pi is the frequency we want. The phase, you want to phase in radian, let it just be. And the sample rate, well, we will touch on this later on, but for now, let's leave it as is. Here we have a stop time. 10 seconds is a long time for 50 hertz. How about I just go for 1 second? Okay. Well, we can keep it as 10 seconds, but the signal is not nice. And it's also a waste of space. And also you can see that we're getting a simulation error. In the real life, that is not what is expected. So you can see the voltage is actually dropping. Why the voltage is dropping? Because the software is failing. Otherwise, the sine wave that we have is supposed to be a fixed one. So be careful, be mindful of limitation of every software using it. The software is not always right. All right, so go for 1 second. Now, okay. Oh, we're getting something interesting as well. So we can see that, how is it working? Okay, we have some phase and we have some bias. Now, how is it working? 1 second still is a long time. How about I just go for 0.1? Well, that's better, isn't it? Okay. Now, for the signal that we have, we can open it. But there is something wrong with the signal, isn't it? This is not a nice signal that we are expecting from a sine wave. Look at this, it's broken. Why it is happening? Well, it is happening because of number of samples. Basically, we have 1, 2, 3, 4. Here we only have 4 samples. Sorry, yeah, 4 samples per cycle. Is that enough? No, it is not enough. And the signal that we're getting is not correct. Actually, in the real world also, if you're analog to digital converter, you're not having enough samples, well, you're not going to get a good signal. Well, sample time was something random, I can say random, by putting 0 here. But now we can actually decide that how much is our sample time. So say, for example, 0, 0, 0, 1. Okay, so it's 1,000 samples. What's going to happen if we go for 1,000 samples? Well, let's see. Oh, it's like that now. 1,000 samples means how many samples? Still, it is not as good. 1,000 samples means we got some samples, but that's not enough. Okay, so maybe we need more samples. 1,000 per second. How about we go for 10,000 samples? 10,000 samples the signal is a lot nicer, isn't it? Okay, well, if you have a 10,000 hertz A to D analog to digital converter, that's a signal that you are likely to have. It is good for many applications, but not for all of them. You want more? 100,000 A to D. So 10 times more samples. Now is the signal. It's a lot nicer, isn't it? Well, by the way, the reason that we're getting sort of wrong signal was because of the frequency error that we had and the sampling errors. And now our samples are good enough and you can see a beautiful signal right here. Okay, what's next? Well, we don't want to just see a signal. We wanted to make some changes on this signal and then see how it works. For example, how about we integrate the signal, or we differentiate the signal and see it? Okay. Well, if you wanted to do any of those jobs, we can do it easily from where? Continuous. Well, continuous provide us many features, including integration and differentiation. So for example, integrator is right here. If I wanted to do integration. What else? Differentiation. Do I want to do differentiation? Well, 1 over s is the Laplace form of integration. But what if I wanted to go for differentiation? Differentiation, derivative is basically du over dt right here. All right, and I wanted to see them, but I like to see them in the same scope, not on different one, because obviously the output for this one is going to be a sine wave, out of this one is going to be another sine wave as well. So how can I see multiple sine waves on the same scope? Very easy. I just go to the configuration. Under the configuration, I can see that I have number of input ports. How many input ports I want? Well, 3. Actually, I can even choose the layout. How the layout want it to be? Well, how about putting them on together, or well, I can put them one on top of the other one. Well, that's possibly not a bad one. Okay, just like this one signal, another signal here, another signal is here. And I go for OK or apply and close that. Okay, now I can see that I have 3 ports. Okay, now I want the signal to be integrated. Well, I connect it to this signal on the same line and send this to the middle port. Likewise, the second one, the same signal. Oh, it's not connected, it's red, but the same signal. I can get the same signal here, or I can take it here. It's my choice. And then again, connect it right here. All right, and I can run it. It takes a fraction of a second to do it, and I am having it. Well, what I see here is a nice signal, but what I see here is just a line, and what I see here is just something going out. Okay, what can I do? I can actually right click here and do one thing. I can zoom out, restore view, horizontal or vertical. I go to restore view, zoom out. If I zoom out, I can see the signal. With this signal, as I am zooming here, well, I can zoom the X and I can zoom Y. As I am zooming, you can see that I am zooming the other one as well. Okay, so it is actually happening at the same time. Okay, but What if I wanted to choose number of cycles, for example, just 2-3 cycles, and then concentrate on Y? Okay, that's good. Yeah, I can actually go for zoom out, or I can just click here and basically choose the signal and see how the signal is working. Well, here is my signal. Now it is showing. Now I can have a better view of the signal. That is not. Or actually, if I know the limits, I can go to the setting and limit that out. Oh, I think it's gone too far. Zoom out, zoom out, zoom out, zoom out, zoom out. Well, sometimes doing it with hand is not very easy. What can I do? Look at this. Zoom out is shift and click. Okay, so I go and press the shift and click. I can zoom that out. Okay, likewise I can zoom that out, and I can zoom this out. So now I can see the signal. Well, I can see actually a good signal here. So the first one, that's the first signal. The derivative of the signal, or I think the integration or derivative of the signal, and the other one. So the 3 signals, and each point I can see that how is it actually behaving and how is it changing. So the second one was the integration, and the third one was a derivative of the signal. So I guess that is enough for this session. Okay, we will continue on